Ma'am, can we start this section?
Yeah, we can.
Good evening, all. A warm welcome to all of you to the talk section organized by IEEE SPS SP. I'm Sweta, and I'm honored to be the host for the night. Together, let's embark a journey of inspiration and empowerment. As K2 the elder said, grasp the subject, the words will follow. It's my privilege to welcome you all to this talk section on advancing signal processing with AI using LLM-driven recommendation system. It's my pleasure to extend a warm welcome to our esteemed speaker of the day, Professor Seema Safar, Assistant Professor of Department of Computer Science of 𝐻𝐼𝐶 School of Engineering and Technology. She is also the current president and the former WISP Coordinator for IEEE SPS Kerala Chapter. Without further delay, let's commence this section. I would like to welcome Asya for the welcome speech. Asya, please.
Good evening and welcome to today's session on Advanced Signal Processing with AI, organized by IEEE Fisat SB in collaboration with IEEE SPS SVC Fisat. We are thrilled to have you all here for what promises to be an enlightening and inspiring talk. It is my distinct honor and privilege to welcome our esteemed speaker, Professor Seema Safar. Professor Seema is an assistant professor from the Department of Computer Science and Engineering at 𝐻𝐼𝐶 School of Engineering and Technology, and the treasurer as well as the former Women in Signal Processing Coordinator of the IEEE SPS Kerala Chapter. Her extensive expertise and pioneering work in the field of signal processing and AI have significantly contributed to the advancements of our understanding and application of these technologies. Today's session, Shepulse, will delve into the fascinating intersection of signal processing and AI, particularly focusing on LLM-driven recommendation systems. The professor's insights and knowledge will undoubtedly provide us with a deeper understanding on how technologies, especially these technologies, are shaping the future of immersive experiences. Thank you, Professor Seema, for joining us today and for sharing your valuable knowledge with us. We eagerly look forward to your presentation. Without further ado, please join me in giving a warm welcome to Professor Seema Safar.
Thank you, Asya.
Thank you, Asya.
Thank you, Shweta.
I will kindly request all of you to stay with us throughout the section, including the virtual photo section at the end. Let's make the most out of this opportunity to learn and grow together. So, ma'am, now let's start the section. I welcome you to share your valuable insights with us, ma'am.
Thank you so much. All right, so we'll begin the session. And the session is actually entitled as Advanced Signal Processing, Advancing Signal Processing with AI using LLM-driven recommendation systems. There are now, from this topic or the heading itself or the title itself, you will be able to see that there is a gap that is being bridged between the AI and signal processing. So through the session, what I'm trying to communicate is how signal processing can be advanced using AI. So let's begin with the presentation roadmap. So I'll start giving you an idea of large language models or LLM. And after that, we'll move on to recommendation systems, followed by how signal processing can be advanced using LLMs. Now, these are the contents that I'm planning to give you. We'll start with a short introduction on LLMs, and then understanding of what LLM is actually, and then we'll move on to some of the examples of LLM, real-time examples or the examples that we use nowadays. And slowly, then we'll navigate onto recommendation systems and followed by signal processing in language models or large language models. Let me begin my presentation with an introduction quote by William Gibson. The future is already here. It's just not evenly distributed. William Gibson is actually an American-Canadian writer who is called as the father of the cyberpunk subgenre of science fiction. Now, why I actually included this quote is mainly because we are trying to distribute many technologies together so that we can advance signal processing. Let's move on to the next slide. So I just want to give you a simple analogy explanation of LLM, not the cliche explanation of LLM. So here's my talking Tom, and this is grandma. And she actually initiates a lot of conversations related to food with her relatives. And Tom is actually hearing all those conversations. And as you can see here, grandma is telling, oh, I'm so hungry. And later on, she does a conversation. I love having some healthy cherries, fruits, and oats for breakfast. Again, she initiates another conversation, but I love having hot biryanis for lunch. Now this grandma, now this Tom is going through all these conversations, listening to all these conversations. And now grandma is like, oh, I'm so hungry. I would like to have some. And she's asking a question, as in when she's about to finish her line. Now you can see that Tom is answering, giving a suggestion on her food, that is biryani. So how did actually Tom say all these things? Or I mean, how did Tom respond to grandma's query, or based on the conversations, Tom was listening to all these conversations, what grandma did. And now Tom was listening to many key terms or the tricky terms, tricky words that like cherries. Next, please. Fruits, oats, and biryani. Now these were the keywords that the Tom actually were listening to, and later on, based on a probability and randomness, Tom came to a conclusion that it is a biryani. So as we are making use of, Tom is actually making use of a probabilistic approach and a randomness based on the conversation that the Tom overheard from the grandma. And so we can say that Tom is this Tom is now making use of some statistical probability and randomness, right? So we can say that it's a stochastic Tom. Next slide, please. So language models are just like stochastic Tom. Why I narrated this is mainly because language models work like this. As you can see now, instead of Tom, here we have neural networks where input is fed onto this neural network, and I get the prediction that I'm hungry, I would like to have biryani. Now, biryani is the generated or the predicted word by the neural network. Now, as you can see here, usually in language model, we have not yet reached large language models, okay? We are just talking about language models only. Now, as you have seen here, now Tom has gone through a lot of conversation or listened to a sequence or a series of conversation, and it is from this conversation that it got trained. Tom is getting trained, and as a result of that, it is answering as biryani. Okay, so we can say that when we are speaking about language models basically takes a sequence or a series of conversations like this, and which is available. It can be a conversation on dialect data, which is available in internet, And that instead of Tom, we have the neural network that is based on some architecture, which is making use of some probability techniques, and it is trained on these data, and as a result, it will be giving us, yes, please. And as a result, we'll be getting the output. So this is language model. So we can say that language model is basically a computer program which will be training a set of data which is actually trained on a set of data to give a required result based on some stochastic approach or some probability. You might have seen this language model in your day-to-day life. You have come across many language models. This is one example, as you can see here. In Gmail or in Google, you might have come across, see in the screen, what you see is, when you're typing CH, you get some prompts, as in there are different recommendations or suggestions that is given by the language model itself based on the data that it has experienced. So this is an example of a language model. So this is how a language model is. But we are not talking about a simple language model in this session. We are actually talking about larger language models. So our talking terms, now assume that our talking term is having some superpower. Now this, what you see on the screen is a super Tom. You can see a hat in our Tom, and it is our super Tom. Now this super Tom is able to overhear the conversation or listen to the conversation and learn to conversations of many people. As you can see in the figure, it is able to listen to the conversation of, yeah, please go ahead. It is able to overhear the conversation of many people. As you can see here, there are a lot of conversation that is happening here. And now the super Tom is getting trained on all these data. Apart from that, now the super Tom is also trying to explore different places, different countries, yes. And based on this, please don't go ahead. Based on this, now Super Tom is actually trained over a huge amount or massive amount of data, as you can see here. Right. Now Tom is back to his house. And yes, you can move to the next slide. And then Tom gets a question. If you ask a question, when did First World War happen, Tom? Then definitely, since Super Tom has learned a massive data set and it is trained on a massive data set, it is going to answer what, as you can see on the screen. So it is giving you an idea of the exact information regarding whatever things, because this is trained on the data that is available on the Wikipedia or on the internet. So now, so we can say that large language models are computer programs which learns and generates human-like language, and they'll be making use of an architecture which is called as transformer architecture, which is trained on a very huge training data. So I just want you to focus on all your attention onto the first point. It is a computer program that learns and generates human-like language using a transformer architecture. See, I know that most of you might be S4 or S6 students, right? Most of you
yes,
might. So you might be familiar with at least some of the, you might have at least heard these terminologies like transformer architecture, right? Or at least deep learning algorithms or machine learning algorithms. Response, please. No?
Ma'am, basically machine learning is placed as a elective for our seventh semester. So
Yeah.
most probably we are going to learn about that in coming semester.
All right. So you may not be, you might have at least heard these terms, right? Okay. All right. You'll be
Yes, ma'am.
studying all these terms, I mean, all these terminologies, because you will get to know all these terms before your project at least. So LLMs are basically based on these deep learning algorithms because they are language models. They understand the natural language which is spoken by the human being. Whatever language that you are trying to train will be understood by LLMs. So that is the speciality of LLMs. Okay, so please over to the next slide. So as you should understand that LLMs, they are actually trained on massive amount of text data. Now, what is text data? Text data means any data, any sentence can be called as a text. Okay, so mostly all these LLMs are trained on Wikipedias. Okay, and when they get the training on Wikipedia or text data, massive data, they'll try to identify or learn some patterns and relationships inside the language, how these words are being related. Okay, we are now basically they are language models. So, what may be the task of these language model? They may be included in some translating language. See, you might have used Google Translate. You have these language LLM that is working behind your Google Translate, and you might have used some chatbots. Yes, ChatGPT is. See, I'm coming to that point. Please. Yeah. Yeah. So, but the thing is that we are training our LLM onto a massive amount of data, right? But the thing is that this is going to utilize a large amount of computing time and space. Just keep that in mind, okay? And all these technologies or LLMs were this computer programs were powered by an architecture which is called as a transformer architecture. Just keep this name in your mind. Now, this is actually a very famous paper which is entitled as "Attention is All You Need." This was a paper which was uh, developed by Google in the year 2017, and this is the paper that we actually refer to understand all the concepts that is related to language models or large language models. So, most interestingly, the mechanism that is used in this particular paper is self-attention mechanism. Now, self-attention mechanism will be helping the model to understand the word just previous to that sentence and after, and what is the word that is to be predicted just after that sentence. So there is a magical self-attention mechanism that is explained in this paper. You can just Google all this title in your Google, and you can get a paper which was developed by Google researchers, and just try to read that paper because that is needed for your further studies and all, for your projects and all. Okay, even when if you're not in computer science, it's not necessary that you should be in a computer science field. This is applicable for all, I mean, irrespective of all disciplines, this is applicable. That is why I mentioned that this paper is actually a very good paper where you can focus on. Now, this is actually the picture actually shows you how they are actually trying to get the subsequent tokens. Now, this is how the cat jumped onto the dash. Now, dash is what is predicted by the model. Now, how does they predict that? They'll make use of some probabilities. Now, this is how the data set will train your model. As you can see in the figure, the data set will train your models and a probability number or a score will be generated for each word. See, as you can see in the figure, little will be having a 0.4 probability as per this result, and big is going to have 0.6. And after little, it can be little followed by a box or a little bed. Now, little box is having higher probability because there is a, it is mostly likelihood that after little we never use a sentence like little bed. So that is why little box is given higher probability number. And there in big also you can see that there is a table as an object and a couch as an object, right? But the probability is just a second, please. Over to the previous slide. Yes. So big, it can be more attached to the word table than a big couch, right? That is the reason why the probability is 0.7 over there and 0.3 here. So this is how you should understand an LLM. Please go ahead. Yeah, now let's see an example of LLM. Have you seen this icon? Anybody can answer, please.
Ma'am, that's the OpenAI.
Yeah, it's ChatGPT, right? Yeah, OpenAI. Yes. Next animation, please. Gregory. Yeah, so this is actually ChatGPT was developed by OpenAI, right? Now this is the screen that shows you that usually pop-ups when you type in your ChatGPT, and there you can see two language models are working at the back end. One is GPT 3.5, and now we have GPT 4.0 as well. So now these are the two language models, or the large language model that is working behind your in your ChatGPT. Okay, so now LLM is actually responding to your queries. Understand that. Next, please. Now, this is again an example of LLM. Now, this is Palm 2, which is developed by Google. Now, this is same as that of, this is also a large language model which responds to the queries that respond to any query that is given by the human. Next, please. Now, again, this is another LLM that was introduced by Google, that is Palm 2. This is actually considered to be the first AI doctor. You can just Google it and read if you want the technologies behind it. This is basically the technology behind is the large language model, which was huge, which was trained on a huge or a massive medical data. And based on that, this is actually able to give decisions, make the decisions taken by the doctors a bit more faster. They help them to take decisions in a better pace. Now, this is an open source LLM example, which was developed by Meta and our Facebook. Meta and Microsoft, they introduced Llama 2, that is the latest version, Llama 2. Now, these are all, now the specialty of this model is that it's an open source model. Now, what do you mean by an open source model? Any idea of what do you mean by an open source?
Ma'am, it's easily applicable to the other users to freely have its applications used by the public.
Yeah, and that is actually meant for open source, means something that is meant for the developers. So developers, they have the flexibility to make any developments that can be done. Okay, but that is not applicable for the other two previous models that we saw. This is an open source model where you can find it in a website. You just Google it as Llama and then Meta Llama, then you will get a screen like this. Over to the next slide, please. Yeah, you'll get a screen like this. This is actually an open source page where you can download the models and you can use it. You can use for your development purpose. And you are flexible to make any changes, and you can make your own model as well. You can fine tune the model as well. I mean, you can make the model adaptable to your application as well. Okay, see, language, before moving on to recommendation system, let me tell you that LLMs are large language models which is actually trained on languages. But they are, it's not language, it's text. which is trained on a huge text corpora or a text data set, which is taken from internet, and it can be trillion, million data set in which it may be trained. And based on that experience, that is how it responds. That is why whenever you give a query in your chat GPT, you get to have, they may not be emotionally trained. I mean, even ChatGPT were also trained in such a way that they were not having any negative impact on people. So negative attitudes were restricted in ChatGPT. So you can just go for, just Google it and do the extra reading if you want to know about it further. It's really interesting how they try to train it on positive attitudes and to get rid of toxic dialogues. Because see, any type of questions can be given in large language models, right? So a GPT or a large language model should make sure that they do not give any toxic replies. So they were so particular that they trained them on such restrictions. There were restrictions on against toxic data. So that is large language models. Yes, so now what we are going to navigate is, we are going to navigate onto the next technology, that is recommendation systems. Now, what is a recommendation system? Animation, please. Have you seen the screen anywhere? See, you might be doing Amazon shopping, right? Using your e-commerce websites, you may be doing some online shoppings, and usually you might have come across such a page on your in your Amazon account, where you'll get to have certain recommendations based on the either your purchase or your browsing history. You have come across such a page, right? And again, another question is, have you seen such a page anywhere? No?
Yes, ma'am. Netflix account.
Yes, Netflix. You might have seen a lot of recommendations regarding, you might like this kind of movie because you watched this movie, you might like this movie. They may give you suggestions in your Netflix. You might have observed that. How is that possible? So there comes the play of recommendation systems. You can see recommendation systems in your Amazon, in your Netflix, and in whichever websites that you're, or social media platforms that you're using right now. So we can say that recommendation systems are basically information filtering system, which actually provides recommendations to the user based on the preference of the user, or based on how or what pattern the user is actually following. Based on that, recommendation systems will be giving you recommendations. So you might have come across, we might be doing it in our day-to-day life mode, right? We may be using Amazon's, Netflix, Flipkart's. See, all these things will be using recommendation systems. So this is an example of how you can understand your recommendation system. How do you, now let's see how recommendation systems work. That is what I want to show with the help of this diagram. As you can see in the figure, you can see one person riding a bicycle and another person standing over there. And the other person, the normal standing person, usually likes 3 food items that is listed over there. It may be a burger or something on a plate, something related to some drinks. Now, how recommendation system, don't move, slide then now the thing is that how recommendation system works is, recommendation system, this person, a recommendation system will be making use of certain algorithms. There are certain standard algorithms for that, They'll make use of the certain algorithms, and based on that, they'll try to find out a similar person who's having the same pattern as that of this person. Okay, I mean, if you can see a person who's riding a bicycle over there, and suppose that he's also liking the same two products or the same two food items, then what recommendation would recommend to that person the next time he's searching for a food will be that cola. Why? Because recommendation system will try to find out a person who's having a similar behavior as that of a of that person, and find a similar user, and based on the similarity and based on the behavior of that person, recommendation system will try to recommend, as you can see, a red arrow recommending a cola to that cycling person. So this is how a recommendation system works. Next, please. So now, usually recommendation systems will be giving importance for the likes, the friends that we are connected to, whoever we are following, and whatever we are sharing. All these data are taken by recommendation systems. And based on that, recommendation systems will be recommending to the user. Now, as you can see in the figure, second figure, you can see that there are 5 people, and now this is basically a recommendation system for suggesting or recommending books. You can see that person 1 and 2, starting from left, I'm telling, person 1 and 2, or A and B. Now A is reading 3 books, as you can see here. I'm telling the person from starting from the left. Just a second, please hold on while I take my stylus and come. But I think I may not be able to do that, right? Yeah, that's fine. Okay, so we'll let's start from the left side, where I have 2 people, where the first person is reading 3 books. And now suppose the second person is also reading the same book as that of the first person, that the second person is likely to get recommended with the third book as that of the first person. Now that is how recommendation systems work. Go to the next slide, please. Yeah, this is another example of how Netflix actually works. Now, as you can see in the figure, you can see that there's a girl and a boy. Now, the girl and boy, they both watch the same movie. Okay. Blue and the black will be showing that is being viewed by or watched by both the users. And now, what will be the movie that will be recommended to that boy? Now, what happens is, previous slide, please. What happens is, recommendation system will be making use of some standard algorithms to find a similar user of that of the boy. And it finds that the girl has actually viewed the same movies as that of the boy. And based on that idea or that pattern, whatever movie is watched by that girl will be recommended to the boy. That is what the figure shows. Now, as you can see in the figure, the girl has watched the orange movie, the one that is colored in orange. And now, what will the system recommend to that particular boy? Now, the orange movie or the movie that is shaded in orange is recommended to that boy. This is how the underlying technology of recommendation system works. And there are many standard algorithms for that. There are basically 2 algorithms. I've not listed it here because we don't need such technical details here. There are 2 basic algorithms. One is collaborative filtering and the second one is content-based algorithm. So now these are the 2 standard algorithms that is used by recommendation systems. Next, please. So now why we are actually understanding recommendation system, we are trying to understand how LLMs are useful in recommendation systems. Now you understood what LLM is, you understood what recommendation system is. Now you need to understand how LLMs are used or useful, going to get or LLMs improve the recommendation systems. So now, as you can see in the figure, this is actually a figure which is taken from a paper. I've listed the author. Presentation, please. Next. Yes, as you can see here, I've listed the title of the paper, an LLM-powered autonomous recommendation agent. It was a paper which was published in 2023 September. And according to this paper, a user can make use of an LLM with a recommendation system to get a recommendation. And that too, the recommendation is not just now, recommendation systems had many cons, as in the recommendations were not that accurate. But making use of LLMs actually act as that of a human brain. Next, please. It acts like a human brain. I mean, it plays the role of a human brain to parse the user intentions, and based on that only they'll be generating response. We need not go into the technicalities of LLM, but just understand that inside LLM we have a different algorithm that is working around, which actually takes a ranking method of top recommendations, and out of the top recommendations they'll be giving suggestions. Okay, and they have a chain policy that is happening, as you can see in the figure. You can see a chain, an arrow that is going, and intention is fed onto the network. Now there is a network for LLM, as I explained. It's a transformer architecture. It's a sequence of transformers, not just one transformer. It has many transformers connected together to perform the action. And now this transformer will be working on a chain mode, and then they'll study the pattern just like what our human brain does. And then they'll try to understand and they'll generate the response. Next slide, please. So as you can see in the figure here, if you're using LLM in recommendation system, this is how it should be. Now, on the left-hand side, you can see a user asking, can you recommend me some action movies onto the system? Now, the Lang chain is actually an LLM model. It can be either it can be a ChatGPT or a Microsoft Azure model or any LLM models. The icons are listed over there. And this language model, what it does is, it will be trained, since it is trained on a very huge data, it will be checking on the retrieval data that you can see on the top side, which is listed as movie 1, movie 2, and that will be the retrieval QA, question answer data that it will be connected to. The language model is connected to that, and based on the algorithm that is working behind, that is 𝐾𝐃 is the algorithm that is working behind the LLM model. And based on that, it will be giving you an output. As you can see on the right side, the model will be replying, sure, based on your interactions history, you might enjoy Mission Impossible 2. So this is how ChatGPT converse with you. This is how the conversation happens in a ChatGPT. Even if you ask suggestions, you can see that there is an LLM that is working behind your ChatGPT. Recommendation system along with LLMs that is working behind, so that it works as if it will be giving replies as if that of a human being. Yes, next please. So now talking about a bit more technicalities on the paradigms of LLM. LLMs in recommendation systems, not LLM. LLMs in recommendation system can be categorized into two. One is discriminative and the second one is generative. And you can see that in discriminative, next please. In discriminative, you can see that this is an example of a discriminative LLM in recommendation systems, where you can see that the input is a X-ray that is fed onto the model, and discriminative AI will be able to identify whether there is a tumor or not. So that type of models are discriminative LLMs. Whereas generative LLMs are that kind of models where, yes, please. Now, generative AIs, as you can see here, will be helping you to generate. As you can see in the figure, there's a random noise, some faces that is being fed onto the LLM, and the generator AI will be generating a new face. That is how now generative AI is on trend right now, because that is right now there is a boom in AI. That is why generative AI is also in boom, because they are capable of generating faces, generating videos, generating text. Machine will be generating all these things, but people, a human may not be able to understand, identify it, whether it is an AI or a normal human being. So these are the paradigms. Now let's move on to how you can advance signal processing using LLM. So right now we have discussed about LLM, then we discussed about recommendation systems, how LLM in recommendation system is going to help you. Now we are going to see how you can advance signal processing using this LLM. So now this is the core part of our topic, advancing signal processing using LLM. So let me ask you a question. Have you ever wondered how Amazon Echo Dot or a Google Home understand your questions? You might have used, or you might be having all these digital instruments or devices at your home. And you might be wondering how this is actually able to understand your question. There is a language processing that is happening at the back end. But the thing, what is the main difference with the language with the data that we are mentioning in this perspective and the previous perspective that we explained? In the previous perspective, we just discussed about LLMs where we rely on textual data, where the input is a text data and the output is a text data. Now, what is text data? It can be a sentence. It can be an English sentence or a Hindi sentence or a Malayalam sentence. It can be any sentence, right? Now, it's not a huge task to convert a text or a sentence into an audio file or a signal. Audio is something called as a signal or a wave, right? So now when we are talking about advancing signal processing using LLM, the thought or the perspective or the scenario that should come to our mind is, what is the type of data? Signal processing is the science that is working behind our digital lives. That is why we say that signal processing can bridge the gap between any technology. It can incorporate with any technology so that it can develop the society and bring development for the country. Over to the next slide, please. Now, let's take a scenario where you're using signal processing in home assistance. Now, what is the peculiarity of home assistance? See, as you can see in the figure, there is a home assistant over there. That orange device will be showing you the home assistant. Let that be an Amazon Echo Dot. Okay. And what is actually a home assistant? What is a home assistant?
Ma'am, someone like Alexa is an example, I guess.
Yes, Alexa is an example of a home assistant. Now, the thing is that Alexa is a home, it is actually a word, right? So a home assistant is basically, see, if you have some signal to pass, in normal systems, if you want to pass any, or if you want to pass any message or any voice messages, you can just make the device, you need to hold the device, and you just need to, normally what do you do when you want to record a voice? You'll just press on the recorder button and you'll input your voice. But is that the same way that we do in home assistants? No. The home assistant device may be elsewhere in your home. It can be at any part in your home. The thing is that there is actually a signal processing that is to be happened in a home assistant, where The user will be telling something, and that message, as you can see in the figure, whatever information the user is telling, or whatever query the user is passing, that has to reach that particular device. Right, over to the next slide. But is that the case? What it encounters? No. See, the user may be elsewhere in the home. It can he or she may be in somewhere in the room, and from there they'll have to input the query, but the input or the device will be elsewhere at some other place. It will be at a distance, at some distance from, there will be a distance that will be between the user and the device. So the chances are that there are a lot of noises at the background. It may get superimposed with this particular signal. So how does the home assistant actually understand what is noise and what is not noise? So a signal processing is actually required in such home assistants. Right. Over to the next slide. So many signals may get interfered onto the device. Next slide. Now, as you can see in the figure, so because of that, using LLMs are actually working behind this particular, all these devices are trained on languages or speech or some audio, and there should be some triggering word that should trigger that device. Now that trigger word is actually Alexa or OK Google. Now, if you're randomly talking, it may be considered as a noise. But the triggering word that you use during your signal processing, during when you're using such home assistants, either you call it as Alexa or you just mention as OK Google. Right. So there is a triggering word that is happening. Now, it is with the help of this triggering word that the device is able to understand which is noise and which is not noise. So that is the main challenge that is faced by our system, a home assistant system, and there is a challenge that is faced by signal processing there. Next slide, please. So this is how now as you can see in the figure, now suppose that is the device. Now there will be a lot, now the blue, green and white may represent a noise, and yellow will be representing the information that is passed on to that particular device. Next, please. So home assistants should be able to successfully analyze the noise out of the signals. So that is the challenge, and that is the place where LLMs come into play. So what is the best signal processing algorithm that can be used to analyze the noise or cut that particular noise or refine that particular signal properly so that home assistants work in an accurate manner? There comes the relevance of using LLMs in signal processing. Over to the next slide. So now this is actually a paper which was recently published, that is in May 2024. I've just taken a snapshot of that paper. And this was actually developed by, the paper was, the authors of the paper are from Stanford University, and they have come up with a work towards signal processing in large language model. If you get to, if you have time, it would be better if you could read this paper properly. You may not understand everything, very clearly. If you read it once, you'll have to read it either twice, thrice, or maybe 5 times. Only then you will understand what is the mathematics that is working behind. Because in this paper, what they're trying to highlight is, next, please. What they're trying to highlight is this paper actually introduces, this is actually a paper which was developed by from Stanford University, and it's a very recent paper and a very recent research work which actually says that what is the idea of applying signal processing inside a large language model? Not any work has happened by incorporating signal processing inside a large language model. And so right now we have an explosion of generative AI, right? We can club or we can bridge 2 technologies together according to this paper. That means we can club two fields, which is the field of signal processing and the field of large language models as well together. And they're trying to bridge that gap that is existing between the signal processing and large language model. And in this paper, what they are actually trying to use is they're trying to use a fast Fourier transform method to polish the signals so that it can be analyzed in large language models in a better manner and with greater accuracy. It's a very interesting implementation. If you get time, please do read the paper. You can get to download it. Just Google it and you will get the paper. Otherwise, if you're not getting the paper on Googling, you can just type Google Scholar and go to Google Scholar and then type towards signal processing in large language model, and you will get an archive of that paper. Just download it and read it. Okay, at least the methodology that is being followed, you might understand it, because more than me, I think you will understand, because it's more on the electronic side. I mean, all the Fourier transform patterns, function that is applied to the signal, so that they'll try to extract all the signals in a frequency domain, and they're trying to extract information in a very rich manner. So, okay, over to the next slide. Yeah, so now we can say that there are certain, how can you innovate signal processing using LLM recommendation? Now, I have listed some points. The first point is you can enhance your data interpretation. Because we have natural language processing, or the language processing things, which is LLMs, which is trained on vast amount of data, we can say that we can get a better understanding of the data. So as a result, the signal processing techniques can be improved. In similar manner, again, semantic understanding, which means since LLM is again trained on a huge data, you can understand the meaning of the text so properly, and based on that, you can provide a better accuracy. Over to the next slide. And yes, obviously that can lead to intelligent recommendations, where you can intelligently, LLMs help you to select the algorithms intelligently using recommendation algorithms, and you can optimize the parameters that is to be fed when you're doing a signal processing thing. And the processing also can be adaptive to the domain, whatever domain that you're using. So in effect, the recommendations can be made intelligent. Next. And of course, automation and efficiency in terms of what, since we are adding a language model at the back end of signal processing, the workflow design is going to get automated. And as a result, you can also add on to real-time data, and real-time processing also can happen if you're using LLM recommendation systems at the back end. Next, please. And apart from that, there are many cross-disciplinary applications in healthcare, that is in the field of medicine, in hospitals, and for doctors, as we saw in our previous slide, and in telecommunications, and even for environmental monitoring, weather forecasting, and so on and so forth. So now let's talk about how to empower women in signal processing, making use of all these LLM-based recommendations systems. Now, the first thing is that they can enhance problem-solving capabilities, because you are trying to find an innovative solutions using LLM-based recommendations. With that, you can find solutions to whatever real-time problems you can possible that is applicable. I mean, that is applicable to all real-time problems, and it can also be applied to interdisciplinary applications, as we explained in our previous slide. Next. And the second thing that I wanted to communicate is that when you're trying to empower women in signal processing, that is where we are focusing on. Now, work-life balance and flexibility is again a big factor, right? So with the advent of this LLMs and recommendation system, you will get to have all those know about what all how remote learning can be done, and you'll get to know what are the different courses that is applicable in the field of not only in the field of signal processing, but whatever field you're trying to work on, you can make use of this LLM platforms to understand and get suggestions, and you can make use of AI tools for time management and scheduling as well. Now, apart from that, there are leadership and entrepreneurship support. Entrepreneur support in the sense that as you can see that there are a lot of opportunities since we are trying to drive AI onto a signal processing system. You can try to build more and more technologies, and because of that, you'll be able to plan different ventures in signal processing, and you'll be able to provide guidance that will you'll be having an AI driven recommendation system at the back end, right? So with that, you'll be able to get guidance on certain funding and marketing opportunities as well, and this will also help you to bring about or develop some or to recommend some leadership training programs and resources as well. So to conclude, let me conclude on a note by saying that the most dangerous phrase in the language is, "We have always done it this way." Now, this is a phrase by Grace Hopper. She is a British computer scientist and a renowned writer, and she's an expert in computer in advanced computer technology, in advancing different computer technologies for the welfare of the country. So what she says is, see, we have always done it this way. I mean, if you are going through the same path, it is not going to bring any change to the society and to the technology as well. So think differently and try to apply some innovations from your part, try to bring developments to the technology and to the society. So with this note, I'm coming to the end of my session. Thank you so much.
Thank you, ma'am. Now it's time for question and answer section. I request the participants to clear any doubt they may have related to this topic. So now is your time, guys. If you have a doubt, you can clear it.
Ma'am, I had a doubt regarding if you're starting in the field of AI and ML, which would be a good language to start with? Is it Python or any other language? Do you prefer suggesting Python or any other language it could be?
Yeah, I would prefer Python. Why? Because there are a lot of community support from Python that you may get, because there are you can get to have some accounts in Kaggle. You might be knowing Kaggle, right? You create some accounts in Kaggle. If you're not known to that platform, just type 𝐾𝐃𝐕𝐀𝐍𝐿E, and there you get to know that there are a lot of projects in Python, and Python comes with all the libraries. I mean, whatever technologies are happening right now, there are libraries that is coming up to support all these technologies. So I would prefer Python, not only because of that, it's so easy to learn. It's more like English. So I would prefer Python.
Okay, ma'am.
Yeah. Any other questions? Yeah, I can see 61 participants.
Is there any potential misuse of AI?
Sorry?
Potential misuse of AI?
Yeah, there are a lot of misuses happening right now, especially in generative AI field. Last day also we saw that in news, right? Some people will try to taking the photograph of a one person. It can be either a photograph or a video that is being generated, See, you can generate a video mimicking me. It's not mimicking, same as you may think that I'm presenting that video, but I may not the person who is presenting that video. There may be some hackers that is working behind it, and you may get attacked. So there are chances of attacks in AI, especially in generative AI. See, every technology comes with the advantages and disadvantages. So ethically making use of all these technologies is what we can say. Yeah.
Ma'am,
What
Yes, Jilha.
industry is currently benefiting AI.
Industries. See, which industry is not benefiting AI right now? See, when you start doing your project, you will get to know that. Jilha, which semester are you?
6th semester.
6th semester. See, when you start doing your project, you will get to know that. See, in cancer detection, if you want to detect a cancer, you can make use of AI algorithms. You just need to train your a model on different cancer data set. You can collect it on real-time basis, either from hospital, and then yes, you can build a very effective model using AI to detect a cancer. That's in medical field. Now, in your education field, suppose that you want a suggestion for a course or a career guidance or a course suggestion. In that case, also you might have seen that in most of the websites they come up with chatbots now. Now, chatbots are actually trained on this. They are basically LLMs. They are trained on massive data sets, so they know what is to be taken. I mean, just as a human being, they are logically connected to all the entities, right? So you can understand most of the websites nowadays come up with a chatbot so that students can get suggestions regarding the course, regarding the branches that they can prefer. And yeah, in every field, see, I was talking about medical field, education field. Now, even in Swiggy, you get to have this AI platform that is working where you get the suggestions of your food. And in traveling, and when you're booking hotels, there is AI everywhere now. Only thing is that what or how accurate your AI is. So definitely you'll be doing your work on, I mean, most of you will be working on building a product like that. It can be a hardware as well as a software, but most of the electronic students will be focusing on hardware related projects where you'll take on real-time data and then you'll get to find a solution to that problem. Okay. Any other questions?
Ma'am, just a personal preference question I'm asking.
Yes,
would you choose ChatGPT or Gemini? Just a simple question.
I would not prefer. I would not prefer ChatGPT. Why? Because most of the time, I have worked with ChatGPT. I have got a wrong information from ChatGPT most of the time. So I don't prefer ChatGPT. I would prefer Gemini.
Okay, ma'am. Okay.
Yes, but I haven't included Gemini in my slide. I just forgot to add it. I actually added Gemini, and I had actually added the a screenshot or a snapshot of the company which developed it, but I forgot to add that after in my final slide.
And I asked it because at this particular moment, basically ChatGPT and Gemini are against each other very much. So that's why I just wanted to know your preference.
I understand. Any other questions? Anyway, it was nice. I mean, it was so interactive, and I'm so happy that I had a session with you. because I'm working on my current PhD is on LLMs and recommendation systems. Even I was I took this topic. Why? Because I wanted to study more and get prepared more to teach you and make you understand in a simple manner. So that is why I chose this topic very particularly. So thank you so much for joining.
Thank you, ma'am. Now I like to call upon Shivani for saying the word of thanks and presenting a momentum.
Thank you, Seema ma'am, for providing us with your insights on the topic advancements in signal processing using AI with LLM recommendation systems. It was very much informative to understand and get to know more about the technology of AI and how it actually works efficiently with signal processing and its concepts. We are very thankful to you for joining this session. Now we would like to present you with a virtual memento.
Thank you.
Thank you, ma'am.
Okay, thank you all. Shall we leave then?
Ma'am, before leaving, yeah, Shweta, please continue.
Okay, thank you, Gregory. And I request all the participants to kindly switch on the cameras to take a snapshot of this section. So please, everyone, please on your camera.
I think we have a feedback from circulating in the chat area. You can fill that also.
I kindly request everyone to switch on their camera so that we can have a proper good photo. Okay. So in the count of 3, 3, 2, 1. One more. 3, 2, 1. Thank you, everyone.
Thank you, guys. I request all the participants to fill the feedback form before leaving the meeting. Once again, thank you everyone for being part of this meaningful celebration. Have a wonderful day ahead. Thank you, ma'am. Thank you so much.
Thanks a lot. Bye. Good night, everyone.
Good night, ma'am. Bye.
Okay. Bye.
Bye.